Let me record it. You gonna verbalize stuff tonight, or did you send me anything?
I mean, I'm sending you a couple pictures right now.
Okay.
See, hold on a second. What's up, stupid shit?
You must have your final on, I'm guessing, either Friday or next Monday.
Next, actually, this final is next Wednesday.
Oh, really? Okay. I just saw you had 3 sessions scheduled before Thursday and then none scheduled next week, so I figured there must be a final coming after this 3rd session.
Oh, correct. Yeah, we don't have any. Oh, well, I need to fix that. Probably need to just schedule a couple more. Alright. I sent you 2.
Okay. Does your computer say sent yet?
Yes, sir.
Okay, I think we're on a slow internet day. That may be why your microphone isn't, why we don't have audio, may have something to do with the speed of the internet. It still hadn't come through. Did you send it to David Cowan, 1949?
Yeah, I did.
Same as you've sent all the others.
Yeah.
And in the past it's taken a while. I think it has something to do with your location in the King Carl Valley, to be honest. I get quite a few students that seem to face slow internet speeds coming out of there. And it affects anything from them sending file attachments, like you, and in fact Dylan has a terrible time sending me files. They just take, sometimes they take like 10 minutes to get to me. And I never understood it. And I'm still not sure I fully understand it, other than if the internet's running slow coming out of King Carl. You know, I could see there being a hub that handles all of King Carl in the valley. And if everybody's using the internet at a particular time, it might slow down for everybody. I still haven't gotten this file. Can we verbalize something while we're waiting for it?
Yeah, I can verbalize one for you.
Okay.
So, solve triangle ABC.
Okay.
And that A equals 43 degrees. B equals 45 degrees.
Angle B or side B?
Angle B is 45 degrees. And side B is 61.
Okay. So, tell me what we're going to do here. I'll draw the picture.
Draw the picture first.
Of the triangle. Yeah, it's worth having a picture. Even if it's not terribly accurate. In other words, I didn't draw this picture very accurate. That's more like a 90-degree angle rather than 43 degrees, but it works for our purposes. Now, what am I going to use to solve this triangle?
1 second.
It's not a right triangle. When you do not have right triangles, you can't just use standard trig functions. You got to use a law of something. Either the law of sines or the law of cosines. What has to be used when you're solving triangles that are not right triangles. They always give you 3 pieces of information. And that's enough to solve the triangle in most cases. There's an occasional ambiguous answer where there's 2 possible triangles from the 3 pieces of information they give you, but that's not going to be the case here. Why?
Because we have two angles?
Right. Which means the third angle can only be what?
It can only add up to be 180.
Well, it's 180 minus the sum of these two. So it's 180 minus 88. That angle's got to be 92.
Yeah.
Now, certainly it cannot be ambiguous anymore. If we've got three angles, it's a unique triangle. There is only one answer. But we still got to solve for side C and side A.
Okay.
Tell me how to do it. I'll give you a hint. You got to use the law of sines. The reason you got to use the law of sines is because you have the relationship between an angle and its opposite side. Whenever that is true, you're always using the law of sines. Not the law of cosines. The law of cosines is required when you don't have that relationship.
Yeah.
Okay, so using the law of sines, solve this.
Sine 45 degrees equals 61 over A.
No, it's the sine over its opposite side equals any other angle, the sine of 43 over A.
Oh, yeah.
It's this divided by this, it's the sine of the angle divided by the opposite side is a constant. It's the same as the sine of that angle divided by that opposite side, and it's the same as the sine of that angle divided by that opposite side.
Okay.
And now there's only one variable there. So you can solve for A. Go ahead and do it, just so we can finish this problem. Give me a number for A.
Oh, good. Sorry, I gotta look at my calculator now.
Yeah, for sure.
So then A is gonna, so then A equals sine 45 over 60 sine 43?
No. That's why I wanted to make sure you could do it. What's the first step in solving for A?
Oh, wait. Would it be,
Cross multiply.
Yeah.
So after cross multiplying, I get the sine of 45 times A equals 61 times the sine of 43. Now divide both sides by sine of 45. So that's what A is.
So,
Let's come up with that number.
alright. 61.
61? Really?
No. Oh, I was just starting to say my equation. Alright, there you go. 58.83.
I'm sorry, what again?
58.83.
58, right?
Yeah.
Does that make sense?
Okay.
So, no, it does make sense. In other words,
Oh, yeah.
in other words, when I ask, does that make sense? We want to compare. One thing you know about triangles is the shortest side's always opposite the shortest angle, and the longest side's always opposite the longest angle. Is side C going to be bigger or smaller than 61?
It's going to be bigger?
Correct. Because that's the biggest angle, 92 degrees. So the biggest side is going to be side C. We still got to solve for it. You don't have to use a different relationship, though. In other words, we can stick with that right there. That is our constant for this triangle. The only thing we need to change is the right side. What's the right side?
It was,
Using the law of sines. Relate angle C with side C.
Sine 45 degrees over 61 equals sine 92 degrees over little c.
Okay. Now, notice that we keep having our unknown in the denominator, which makes for a little bit of a difficulty algebraically. Okay? If this is true, then I can flip both. I can always say that 61 over sine of 45 is equal to c over sine of 92. And the law of sines works that way. It's just not sine of a over a. It can be a over the sine of a, as long as you leave it in the same order. You see what I'm saying? Now, the advantage of doing it this way is I don't have to cross multiply. All I got to do is multiply both sides by sine of 92. So my answer is 61 sine of 92 over sine of 45. So it's considerably easier to solve for your unknown if it's in the numerator. And maybe not considerably, but you did have a problem solving for it in the denominator, and I don't think you ever would if it was in the numerator. So what's this number?
It's 86.21.
Yeah, and that makes sense too. That's the longest side of the triangle. And now that whole triangle makes sense. All right, let's see if your document got to me. No, did not.
That's kind of weird.
What is going on? How come I could never figure out why that happened with Dylan either? And what would happen is 15 minutes after our session was over, I'd get this file.
Seriously?
Yeah, it would be crazy, and I'll bet that happens tonight. I mean, let me just verify that you sent it. Try sending it. Is it easy enough to send again? In other words, is that picture in the gallery?
Yeah, here, I'll send it again.
Well, send it again and make sure this is what's in your default when you type in DA.
Okay.
Because I have had students before that misspelled it once, and then forever their defaults had both of them. The misspelled one and the spelled one, and they never knew which one it was, of course. No spaces, no caps, no, and it's C-O-W-A-N.
It doesn't look like they sent.
No, it doesn't. Yeah, if it doesn't say sent, then it wasn't sent. It's got to get to the point where it says sent. And if it's still trying to send it, then it's definitely slow internet going on.
Yeah. Can we let's see if can we hang up for a second and see if I can send it with if we can hang up.
You mean hang up our phone connection or hang up the GoToMeeting connection?
Yeah. That's fine.
Well, how important is it that you send it?
Well,
is everything on there something you can verbalize?
I'll try to verbalize the next one. Yeah, I guess I can try to verbalize.
Let's just verbalize it until we can't do it anymore. In other words, when you come to a problem where you have to interpret a graph, well, then we will hope that your file has gotten to me. But I don't quite know what other options we can do. I honestly don't think it has anything to do with GoToMeeting.
Yeah.
So I don't think that disconnecting from GoToMeeting and logging back on would do anything to your outgoing email server. Your outgoing email server is using Gmail, right? What email service do you use?
Gmail.
Okay, so you have a Gmail address and you're sending to a Gmail address.
Yeah.
And it's still having problems. Wow. Of course, even Gmail's got to go through the main hub But you obviously have internet speed because you're able to connect to GoToMeeting, but not having that audio is a flag. That tells us things about what's going on with your internet, I think. All right, go ahead and we'll verbalize it and get as far as we can verbalizing some of these.
All right.
Maybe by tomorrow or Thursday things will have changed and you can send me pictures. Or by then I will have gotten the file you sent already. Probably by tomorrow I will have. So go ahead and take pictures of everything that you think we're going to go over this week and send them to me as soon as possible. If you already have all of the review material, send them to me one file attachment at a time. And you don't need to do it before our session today, but if you do it after our session, then by Wednesday's or tomorrow's session, I don't know when your next one is, I will have gotten that file. All right, until then, let's verbalize.
All right. So, what's the one? Oh my God. Let's go with.
Do you have it? Let me ask you this. Do you have any triangles you have to solve where they only give you one angle?
Yes.
Let's do that one.
Okay. Well, I don't have to solve it. I have to find the area of it. Can we try this one?
Okay.
So it's a triangle, and it's an obtuse triangle. The hypotenuse is 12 centimeters. Is what you have. A side AB is 8 centimeters. And then angle B is 28 degrees.
Okay.
Let's find the area.
Okay. The area of a triangle is 1/2 base times height, right? Well, we don't have height. We could use 8 as a base, and we could use 12 as a base, but then we still wouldn't have a vertical height. So for these kind of problems, finding the area, you use the sine. In other words, the area is 1/2 excuse me, that's area, not A. Area is 1/2 of the two sides that you have, 8 times 12, minus, no, times the sine of 28 degrees.
That's literally all it is.
That's literally all it is. Now, if you forget, notice that if this was a 90-degree angle, then it would be 1/2 base times height, because the sine of 90 is 1.
Yeah.
So that's one way to always check your formula. In other words, this is a terribly difficult formula for me to remember for some reason. I don't know why. Even just now, I just kind of draw a block on memorizing it. And I finally figured out the way to memorize it is to, see, I'm even getting a note from GoToMeeting saying you may be experiencing degraded audio quality. Yeah, I'll say like none. Yeah. But anyway, yeah, so it's not 1/2 the base times the height, but 1/2 of the two sides you're given times the sine of the angle between them.
Yeah.
So as long as they give you two sides and an included angle, it's always that.
Okay.
And it doesn't really matter whether I label this like that or not. In other words, if they give you two sides and an included angle, this is the formula. It's 1/2 the two sides multiplied together times the sine of the included angle.
Yeah.
So you don't even have to label it. In fact, labeling it can almost be confusing because I labeled A, meaning area, and then I labeled the triangle A, and all of a sudden I was confused. All right, what else?
Let's see, I have one that said, write the equation in standard form and graph the ellipse. 16x squared plus 4y squared minus 64 equals 0.
What's the standard form of an ellipse?
It's like a circle.
There's a standard general equation of it. And you want to memorize these. You want to memorize the ellipse? Have you gotten to the hyperbola yet?
Yeah.
Okay. Well, there's 4 equations you got to remember. Parabola, circle, ellipse, and hyperbola. And ellipse and hyperbola actually have 2 other equations you got to remember because they can be vertical or horizontal. So you got to get these general equations memorized. Okay, here's the general equation of an ellipse. And more specifically, this is the general equation of a horizontal ellipse. If it was a vertical ellipse, my a squared would be under the y term.
Yeah.
So there's the general. Always be able to know that. Okay? And our goal is going to be to take this equation we have and get it into this format. Now, the one thing that I've done this long enough that I know is that h and k are 0 for this problem.
Okay. But why?
Because there's no x term and there's no y term. If there was an x term, I would have to complete the square, and then I would end up with an x minus h squared. So it wouldn't be at the center. But because there's no x term and there's no y term, I know that the standard form is just this. It's x squared over a squared plus y squared over b squared equals 1. So that's what we have to turn this thing into. So what's the first step?
Take the square root.
No. Right now we got everything equal to 0. Let's move that 64 over.
It's over 1.
Okay, you see where what we started with is what we got now? Correct? In other words, this equals this. You with me?
Yep, I am.
Now, I got to get it equal to 1 on the other side. That's the key. In other words, the standard equation of an ellipse is equal to 1. So I got to do whatever you got to do to make this right side 1. I could subtract 63 from both sides. That would do it. But that wouldn't help me on the left.
Yeah.
What else can I do to make it equal to 1?
To make it equal to 1?
Mm-hmm.
Do I divide by 64 or something?
Yep, always. Always divide by this. And if I'm dividing the right, I'm dividing both terms on the left. Okay. Now I get 1 over here, so I got part of the general equation. What's my left?
Squared, that would be 4x squared.
No?
It would be x squared over 4.
Okay. What's this one?
That would be y squared over 16.
Okay.
No.
Now, notice, we've got it in the standard format. Now, hold on. I thought that noise was on your end. It's on my end. Let me go turn my TV off. Hold on a second. Alright. I thought that was coming from your end. I was going to say, you watch CNN also, huh?
Yeah.
Okay, so I've got the equation down to this. Now, what's A?
A equals 2.
What's B?
B equals 8.
Square root of 16, not half. Square root of 16.
Yeah, that's 4.
Okay, now there's a problem. A has to be bigger than B.
Yeah, that could be a problem.
Well, that means I got them reversed. That means A is 4 and B is 2. In other words, this is not a horizontal ellipse, this is a vertical ellipse. This is an ellipse that looks like this, as opposed to like this. Remember what A is. A is this distance right there. It's the longest radius. Well, in my vertical ellipse, that A is on the y-axis. So A has to come under the y term if it's a vertical ellipse. And it comes under the B, or the x term if it's a horizontal ellipse. So I didn't know until I solved this which was bigger, because I had 16 as a coefficient and 4 as a coefficient, which is the opposite of what you get when you divide both sides by 64. You end up with a bigger number under the y than you do the x. Therefore, that's B squared, that's B squared, and that's A squared. So A is actually 4 and B is 2, and the equation for the ellipse is what we had. In other words, it doesn't change the result. You still get x squared over 4 plus y squared over 16 equals 1. But what was the next request here? Was it to graph it?
Yeah.
Okay, let's graph it.
What?
How do we graph it? Where do we start? You always start at the center. Where's the center of this ellipse?
The center is
It's H and K is what it is.
origin.
In other words, right. In this case, H and K are both 0. There's nothing in the numerators. So you're right. The center of our ellipse is the origin. Now, I know it's a vertical ellipse, so I know it looks something like this. What's that vertex right there?
That would be 0, 2.
0, 4. Remember, A is 4. And A is that distance from the center to the vertex.
Okay.
What's this coordinate? That's called the minor vertex.
That would be 0, 2.
2, 0.
2, 0. Yeah, that's pretty close.
What did you just say? You say, well, yeah, that's pretty close. Okay, what's this one?
That one is 0, -4.
And this one?
That's -2, 0.
Okay, there's only two other important points on this ellipse, and that's the foci. Have you gotten to foci yet?
No.
You're kidding.
Wait, what?
What's this question ask?
It says the equation in standard form and graph the ellipse.
Okay, so they don't ask about foci at all?
No.
Okay. Well, I'm going to introduce you to the concept, because I got to think by your final you're going to be talking about foci. Okay, so the equation, first of all, the foci are approximately there and there. Okay, they're always on the main axis of symmetry, the long axis of symmetry. And this distance is c, from the center to the foci. And c relates to a and b in the following way. C squared equals a squared minus b squared. Not quite the Pythagorean theorem, but close.
Yeah.
For an ellipse, it's the Pythagorean theorem only with a negative sign. Okay, which makes in our case c equal to the square root of 16 minus 4 equals square root of 12, which is equal to 2 root 3.
Yeah.
So the coordinates on that point are 0, 2 root 3. And on this point would be 0, minus 2 root 3. An equivalent distance in the other direction. And now we have all 7 points of this ellipse. And that is, at some point when you finish studying ellipses, they'll always want all 7 points. Okay? And by the 7 points, I mean the center, all 4 vertices, major vertices and the minor vertices, and the 2 foci.
Gotcha.
That's the 7 key points. And you generally, once you have the equation of the ellipse, like we do here, well, now you know what A is. A is the square root of the bigger denominator. B is the square root of the smaller denominator. And C is the figured out by the square root of A squared minus B squared. And incidentally, if you're ever figuring out C for an ellipse and you get a square root of a negative number, you got your A and your B backwards. That's what happens if you get A and B backwards. Notice that we almost did that here. We had B as 4, A as 2, which would have given me the square root of negative 12. Well, you can't ever have C be square root of a negative number. So immediately that should have alerted me to the fact that we got our A and B backwards.
A is the y-axis and B is the...
Not always. No, A is the longest. A is the biggest denominator. That's how you figure out what A is. Well, the bigger number was under Y, right? In other words, when I got down to my final equation, the biggest denominator was under the Y term. That means that A is along the Y-axis, which makes it a vertical ellipse. The only time A is ever on the Y-axis is if it's a vertical ellipse. If it's a horizontal ellipse, then the bigger denominator is going to be under X. Okay? All right. Got another one?
Let's see. Yes. Let's see.
If you have one that has an X squared and an X term, that'd be a good one to do. Or a Y squared and a Y term, because that is one that is not at the origin. And we would have to figure out the centers. And we'd have to complete the square to solve it. So there's a lot more to solving the ones that are not at the origin. So let's do one if you have one of those.
I do not.
Okay, well, if you don't have one, then they maybe aren't going to make you do that. They apparently aren't going to give you ellipses that are not at the origin that would require you to complete the square to come up with the formula. So go ahead and give me ones that are on your review material.
How about, wait, what do you mean, sorry?
Anyone, just you pick. I'm not looking. Hold on, let me check my Gmail and see if anything came in. Yeah, look at all that. All right.
We already did those ones.
You already did these, okay. That's an internet speed problem. And I guarantee you it's from where you live. You have Comcast or CenturyLink?
Number one we just finished. How about number two?
Okay.
I started it right there. You can see.
Yep. Okay, so it's got a mean of 161, which is the center. It's got a standard deviation of 10, so that's good. Now the only thing you want to finish here is wow. Okay. Let me blow this up a little bit. First of all, give me some percentages. What is this zone right here? In terms of...
Between 151 and 161 would be 34%.
Okay. That's 34%. This is 34%. Where's 155 on this? First of all, how much is everything to the right?
Everything to the right is 50%.
Okay, and everything to the left is 50%.
Yeah, exactly.
Now, they give us a number of 155, not even halfway between 151 and 161.
Yeah.
However, the only way I've ever seen anybody do this is linear. So take your 34% and give me the part that is between 151 and 155. And what part is to the right? Actually, the only thing we really need to know is the part that's between 155 and 161.
Yeah.
What percent is that?
Between what, 155 and
This area right there.
That's 12.5% or something like that? No.
How would you figure it?
That was just a guess.
Well, don't guess. Don't ever guess.
Take 34 divided by 2?
Not 2. We're not in the middle. 155 is not the midpoint. It's 6 points away from the mean, and it's 4 points away from one standard deviation under the mean.
Yeah.
So I would say that this represents 60%, right? 6 divided by 10?
Yes, sir.
In other words, you see how I'm getting at? 161 minus 155 divided by the distance between them, that's 6/10. So I'm going to multiply 6/10 times 34%. What do you get?
6 times 34%.
Uh-huh. Give me the answer in percent. What do you get?
102%.
No. It's a little more. What would half of 34% be?
That would be 17%.
Okay, this is slightly more than that. So we need a number somewhere between 17 and 20%. So in your calculator, just take 6/10 of 34, and that's our answer, only in percent. In other words, there's no need to convert this to decimal. Just take 6/10 of the number 34. What do you get?
I got,
0.6 times 34.
0.6 times 34 is 20.4.
20 what?
20.4%.
Okay, that's that area right there. You see why? That's 60% of that zone. That zone was 34%.
Yeah.
Well, we're 60% of that zone, are we not? From 155 to 161 is 6 points. The zone is 10 points. So we're 60% of 34%. So this area represents 20.4%. So what's the answer to their question? What percent of operations last longer than 155 minutes?
That would be 70.4%.
Very good. And that's how you do those. In other words, when they give you, this is the first time we've had one where the point they gave you was not directly in the middle between the other two dotted lines.
Yeah.
So whatever percentage it is, you have to use it. In other words, 156 would have been the 50% point. Then that number would have been 17% instead of 20. But the fact that it's 55, not 156, we got a little bit more. In other words, it's 60% of that zone. What's this zone right here? No, you don't need it for this problem, but just checking, you make sure you know.
That's 12.5%.
That's 13.5. Is that what you said?
No, I said 12.5.
13.5. It's 13.5. Yeah.
Okay.
And that's generally the only 4 zones you need to memorize. And you don't really memorize those numbers. What you memorize is that 68% of the curve is 1 standard deviation away. That's why that's 34 and 34.
Yeah.
2 standard deviations is 95%. And if you add up all 4 of those numbers, you'll get 95%.
Yes.
3 standard deviations is 99.4%. So as long as you memorize those 3, then you can always figure out what each zone is here. Yeah, in other words, you cut 68 in half to get 34, 34. Subtract 68 from 95, you get 27. Cut it in half, that gives you your 13 and a half, 13 and a half.
Yeah.
All right. Anything else on this page, or go to the next?
No, I have another one to tell you.
Okay, I do have a third email. You want me to take a look at it?
That would be just the same ones.
Oh, it's the same. Oh, I see. You resent the same page just because I hadn't gotten it yet. Yeah. Okay. All right. What else you got?
Let's see here. One sec. Okay. I have one that says determine if f of x equals log 3x plus 1 and g of x equals equals 1/3 10x, or 10 to the x minus 1 are inverse functions. I just sent you a picture. Hopefully if you got it.
Don't need it. Just finish reading it again. What was f of x? I didn't catch it.
F of x equals log times 3x plus 1.
Okay, that's not times. That's log of 3x plus 1. It's not multiplication going on. What's g of x equal?
G of x equals 1/3 10 to the x times parentheses 10 to the x minus 1.
Minus 1 is in the exponent?
Oh, no. 10 to the x and then just a minus 1.
Like that. Have I written both of them correctly?
Yep.
Okay. Now, there's two ways you could determine whether g of x is the inverse of f of x. One way is to just solve it. In other words, you know how to solve for inverses. But I suspect they want you to use the traditional way, which is to make sure that f of g of x has to be equal to x. That's what proves they're inverses of one another.
Yeah.
Okay, so let's do that. In other words, let's figure out what f of g of x is. Well, how do I write it?
F of g of x.
The first step is to rewrite this. Instead of g of x, let's plug in what g of x is.
That would be f of 1/3 times 10 to the x minus 1.
Okay. Now, how do I figure out what f of that thing is?
Wait, wouldn't that be... Okay, I'm sorry. Just the way you wrote it, would that make it 1/3 10 to the x minus 1/3?
No. Not unless I missed a parentheses.
Yeah, you missed the parentheses.
So this is 10 to the x minus 1 like that?
Yeah.
Okay, well let's just put the parentheses in down there.
Okay.
Okay? So now how do I figure out f of this thing?
Not sure.
Whenever you have something inside the parentheses that's not x, you plug in that wherever you see x in the original f function. So I'm just going to write the original f function, only now it's going to be what? Instead of log of 3x plus 1, what is it going to be?
Log 10 to the...
Hold on. Let's take it digit by digit. Log parentheses 3. Now, what goes in for x?
In for x is...
This whole thing. Everything that's inside the parentheses goes in for x. That's how you do these. In other words, if you have something, if I put a number, if I said, what is f of 2, you would substitute 2 for x. Wherever you saw x, you would just plug in 2.
Okay.
If I say, what is f of this complicated expression, well then wherever I find x, I'm going to plug in that complicated expression. Well, that complicated expression is 1/3 10 to the x minus 1. Need 3 parentheses there. I'm not done yet. Because all I did was, I didn't add the 1 yet. In other words, I plugged in for x, just like I've done here. 2 parentheses. And then I got to add that 1. In other words, I still got that plus 1 up there. Right?
Yeah.
You with me?
Yes, I am.
Okay. Now the question is all of this equal to x? If it is, these are inverses of one another. So the first thing I can do is cancel that with that. And now I have log of 10 to the x minus 1 plus 1.
Gotcha.
What's the log of 10 to the x?
Log of 10 to the x?
Mm-hmm.
How do I find that?
It's just x. In other words, if the base, which is 10, is the same as that, then the answer is x.
That's just, oh, really?
Uh-huh. In other words, if I said, what is the log base 7 of 7 to the x plus 1, the answer is x plus 1.
Oh, wow.
It's always the exponent. If the base is the same as the argument, your answer is the exponent.
Okay.
Now, we've got this annoying minus 1 here. Wouldn't be so annoying except it's inside the parentheses. In other words, if I've written the problem wrong, and what it really is this, then yes, that is equal to x. Why? Because this is equal to x. And the minus 1 and the plus 1 cancel one another out. So I would get equals x. That means f of g of x equals x, which makes them inverses.
Okay.
Now, if there really was parentheses around that, then they're not inverses. The problem is that because so much of this problem was verbalized, I could easily be missing a parentheses or have one in the wrong spot or whatever. You know what I'm saying?
Yes.
In other words, the first time I wrote it, I was missing the parentheses. So I'm not certain at this point whether these two are inverses of one another. However, as long as we're not sure, we only have 3 minutes. So let's real quick, in 3 minutes, figure out the inverse of f of x.
Okay.
How do I do it?
The inverse of f of x.
Uh-huh. Switch the variables. First of all, call f of x y. So we have y equals log of 3x plus 1.
Yeah.
Now switch the variables. First step. Right? And now solve for y. And solving for y is a little tricky. You have to let this whole thing be the exponent of 10 on the left and the right. The reason being is that if on the right I've got 10 to the exponent log of 3y plus 1, that thing becomes 3y plus 1.
Yeah.
I still got 10 to the x on the left. Subtract 1 to get rid of that 1. Divide by 3, and I've got y equals 1/3 10 to the x minus 1, like that. That looks an awful lot like g of x. Exactly.
Yeah.
So, in fact, one is the inverse of the other. It was a little harder. It turned out it was actually a little easier to prove by just finding the inverse of f of x and see if it was the same as g of x. But that's not the mathematical definition. The mathematical definition is fog of x has to be equal to x. F of g of x has to be equal to x, and g of f of x has to be equal to x. Both of those have to be true if they're inverses of one another.
Yeah.
So I tried to prove it that way, but kind of got lost in the parentheses. So I went back and just found the inverse, and it turns out that the inverse is exactly our g of x. So the answer is yes.
Okay.
It might be easier to do the inverses, although I'm not sure you knew about this little trick here. In other words, getting to this point right here, this is not a trivial solution. That bottom line you see there, you kind of have to get used as to how to solve that for y. And it always involves making that the exponent to the base. Whatever the base is. Well, the base is 10, so I want to make this thing the exponent to the number 10. And since I do it on the right side, I can do it on the left side. In other words, if I gave you this as an equation, if I said 10 to the x equals 10 to this, you would then say, okay, I can equate the exponents, right? That would mean x would be equal to log of 3y plus 1. Well, if you start with this, you can make those things the exponents to any number you want. In this case, I'm making it the exponent to the number 10.
Okay.
That's how you solve for y. All right, Justin, let me just check the calendar here. So it looks like your next appointment is Wednesday at 7. So what I'm going to suggest is at least a half an hour before that appointment, send me anything you want. But send it a half hour early so I get it by the time of our appointment.
Gotcha.
All right.
I'll do that.
All right. Talk to you Wednesday. Have a good one.
Thank you. You too.
Bye-bye.